Of the four fundamental forces in the universe, the only one we can manipulate is electricity. We use it for everything: our phone calls, our entertainment, our safety, and even our driving. Although electricity is the lifeblood of our modern way of life, it wasn't always that way. It wasn't until recently in history that the invention of the light bulb brought us out from the darkness and gave electricity a new place in the lives of every human being. Once we were able to harness its power, the world and the way we live would never be the same. People have long known about this mysterious and invisible force that surrounds us. Ancient Egyptian texts from 2700 BCE describe electric fish as the thunder of the Nile. Electricity would remain little more than a curiosity, though, until 1600, when the English scientist William Gilbert wrote De Magnete. He coined the Latin word electricus, meaning of amber. Later, the English would reshape it to electricity, first appearing in Thomas Brown's Pseudodoxia Epidemica of 1646. Often thought of as little more than a magic trick, electricity was not seen as useful. In the 18th century, Benjamin Franklin conducted experiments on the hunch that electricity, like static electricity, was the same stuff as lightning. But how could it be used? How could we take this energy and make light? The answer would come not too long after Franklin's experiments in the lab by a young inventor named Thomas Alva Edison. Although many people regard Edison as the inventor of the light bulb, it wasn't actually his idea, and he didn't make the first one. The arc lamp was invented by Humphrey Davy in 1800. Humphrey found that if he ran an electric current through two rods and then slowly pulled them apart, they would create an electric arc, producing light. The carbon arc lamp was used to light streets in the 1870s and was truly revolutionary. However, they weren't particularly safe, required a lot of power, and they weren't available to the general public. Joseph Swan, a British physicist and inventor, developed an incandescent bulb around the same time as Edison. Although he managed to get his patent first, his initial designs produced a very short-lived bulb, not long-lasting enough for everyday use. Edison's problem wasn't inventing the light bulb, it was already invented. It was improving it so that everyone could have one. Most people lit their homes with candles or lamps using fire. This itself was dangerous, and house fires were common due to the volatile nature of flames. If a cheap and safe electric lamp could be made, the darkness of night could be a thing of the past. Edison set out to make light easy, cheap, and long-lasting, but he faced many challenges. Luckily, he had a crew of talented engineers working with him to solve these problems. In 1878, he set out to find a longer-lasting light bulb that would work in homes everywhere. With his team at his side, he started experimenting with different ways to make light within everyone's reach. An incandescent bulb works by conducting electricity through a small filament or super-thin string that has a high melting point. It gets heated by an electric current and glows, producing light. There are supporting wires that hold it in place and wires to conduct the electricity. All of this is encased inside of a glass bulb without oxygen. The problem was the filament, though. It had to be bright and cheap. Edison experimented with different materials for the filament, but they were either too expensive or didn't last long enough to be practical. The material had to be durable enough to withstand the heat and not melt or burn away. It also had to be cheap enough that everyday people could afford it. Edison first tried using platinum for the filament. It worked. The material glowed brightly and could stay lit for a long period of time. However, platinum was expensive, and the cost of the bulb would render it unpractical. Edison was forced to pivot to other, cheaper materials. He began to use plant-based resources to make the filament. They tried cotton, coconut hairs, and even cork, only to be frustrated by failure. Edison and his team tried hundreds of different filaments. All of them either burnt too quickly or didn't glow bright enough. Finally, he settled on a material that was cheap and effective: bamboo. Bamboo was everywhere, and its strong fibers could withstand the heat from the electrical current produced. Bamboo was cheap, and the filament from it would last over 1,500 hours. Edison, along with his team, had found the answer of a cheap and long-lasting light bulb. There was just one more problem looming over it: where to get the electricity. This would prove to be more complicated than making the bulb. Now that anyone could afford a light bulb, they needed a way to get electricity to it. Without a steady supply of an electrical current, the bulb was just a piece of glass. Edison was already famous from his other inventions, and making a better light bulb helped attract the attention of big-shot banker J.P. Morgan. Morgan hired Edison to light his entire home with incandescent lights. This was the first home lit entirely by electricity. Edison also had a lab of sorts inside Morgan's home, and the two formed the Edison Electric Company. Although Morgan had a generator in his basement, not everyone could afford one, so the two needed a solution to get power everywhere. So Edison and Morgan began to build a massive power station, big enough to power much of Manhattan. Edison knew that if he could build enough power plants to offer cheap electricity everywhere, everything would change. Edison's men worked night and day, laying thick copper wire under the streets of Manhattan. Soon, most of the city was electrified, and for the first time was lit under the night sky. Edison's design for the power grid became the standard for power grids even today. But where he fell short would lead into another electrical revolution, this time from one of Edison's junior engineers, Nikola Tesla. Edison's power relied on direct current, or DC. In a DC system, the current flows in one direction. There's a positive and a negative, and the polarity can't be reversed. The trouble with DC current is that it only works over short distances, and any power plants would need to be close by in order to work. This would make it virtually impossible to electrify all the homes in America's rural regions. Nikola Tesla developed an alternating current, or AC. AC current is not constant, but rather changes direction in cycles. In America, that direction changes 60 times per second, or 60 hertz. In Europe and other regions, it's 50 hertz. A power plant using AC power can be many miles away from its destination. At that time, Edison and others thought that AC was unsafe, but in the end, Tesla and his alternating current won the war between AC and DC. Edison's improvements on the light bulb changed everything. Not only was the light bulb accessible to most people, the electrification of homes everywhere ushered in a new era of modern conveniences and utilities. Although there were many who improved upon Edison's design, Joseph Swan, Hiram Maxim, and Lewis Howard Latimer, whose improvements are still found in the modern incandescent bulb, no one is associated with the light bulb more than Edison, and his perseverance has withstood the test of time. Gone are the days of kerosene lamps and dimly lit evenings. The incandescent bulb has lifted the night out of the darkness. Today, the technology surrounding lighting has changed significantly. LEDs and fluorescent lighting dominate ceilings of offices and homes everywhere. But no one can forget Edison's contribution to its development and the significant impact that artificial light has had on our modern way of life. Headlights, movie lights, lights at the dentist, flashlights, all have a place in our lives because of the innovation of Thomas Edison.